Blast off. Today we're going to cover two sections, section 1.3 and 1.4. And we're going to start on page 28. If you need to know that, page 28 of the text. And section 1.3 has to do with applications and problem solving. But in real people words, that's word problems. And I know how much everybody enjoys word problems. So we're going to cover this thoroughly, okay? And the first example we're going to start with is problem number 3. Page 28, number 3. And the first word problem has to do with a city park. Let me read it to you. The residents of a downtown neighborhood designed a triangular-shaped park as part of a city beautification program. I don't care. What shape is it? That's important, okay? The park is bound by streets on all sides. That does not sound safe. It's got streets on every side. And then we come to the important part. It says the second angle of the triangle is 7 degrees more than the first. The third angle is 7 degrees less than twice the first. Find the measures of the angles. Man, does that sound exciting? Not really, right? So let's start with the basics. What shape is the park? Let's draw a picture. And as I read the problem, did you hear them reference the second angle and the third angle? So the next thing we want to do is label the angles first, second, and third. Which one do you want to be first? This one? It doesn't matter. Okay, so we'll say this guy is the first angle. What about the top angle? You want him to be second or third? It doesn't matter, okay? Okay, but now you don't have a choice. Okay, so that one is now the third angle. And now that we have these labeled first, second, and third, now we're going to reread the problem and we're going to populate the picture with information. Here we go. It says the second angle is 7 degrees more than the first. Well, what is the first? Do they ever tell me how much the first angle is? And what do we use for something we don't know? X, or a variable, right? And so I'm going to go ahead and say, I don't know what the first one is. I'm just going to make it X. But now that I know what the first one is, I can get the second one. Because it says the second angle is 7 degrees more than the first. How do I write 7 degrees more than the first? Is that what I heard? More than means add. 7 degrees more than the first, and if the first is X, this is 7 more than that. Got it? Now for the third angle. It says the third angle is 7 degrees less than twice the first. What do the words less than mean? Subtract. And the funny thing about less than, whatever's in front of the words goes at the back of the minus. 7 less than, 7's in front, so 7 has to go at the back. Did y'all get that? I'll say it again. If it says that the third angle is 7 degrees less than twice the first, less than is always backwards. Let me write it this way. 7 degrees less than twice the first. Okay, if it's written like this, We know that the words less than mean minus, right? And whatever's in front goes at the back. And whatever's at the back goes to the front. Y'all got that? It's just the way less than works. I'm sorry. That's just the way that works. And I don't really want to keep that there. So did y'all write that down? Bam. And it's gone. All right. So here we go. 7 degrees less than, what did I say? Twice the first. So how do you represent twice something? And you don't even need parentheses, because when you put a number and a letter next to each other, it indicates multiplication. So twice the first means 2 times x. Now do y'all understand how I got each one of those pieces? 7 degrees more than the first. 7 degrees less than twice the first. Yes? And now that I know an expression for each angle, now I can set up an equation. Does anybody know what all 3 angles of a triangle add up to make? 180. So if I take the first angle plus the second angle plus the third angle, that should add up to make 180. So you're going to have to come up with algebraic expressions so that you can write an equation. Man, that sounds cool. Are y'all ready to solve for x? Let's do it. And the first thing I notice is I've got plus 7 minus 7. Bam, and those are just going to cancel. And then I've got some like terms. X, x, and 2x. How many x's do I have? Okay, there's 3 terms, but when I combine them, I get 4x. And that is a trick question. If somebody looked at and they said, how many x's are there? There's 2 correct answers. And there's 3 x's because there's 3 terms, but there's 4 x's because you combine them. And then divide both sides by? Anybody know what 180 divided by 4 is? And now you need to identify what angle that is. Is that the first, second, or third angle? That is the first. Not because we found it first, but because x is labeled the first. X by itself. We also need the second angle. Do you see the second angle is x plus 7? So whatever x is, I'm going to add 7 to get the second. 45 plus 7? And I also need the third angle. Question. You were looking at that awful mean.
Shouldn't it be 52?
I'm sorry. Did I hear 53? Or did I just write it incorrectly? Man, that's why you were looking at that like that. Have a nice day. Will I see you tomorrow?
Yes.
Okay. All right. Now, how do I get the third angle? Well, I plug in, right? So 2 times 45 minus 7. Because x is 45, 2 times 45 minus 7, whatever that is, that's the third. Does everybody see how we get all 3 answers? Is there a way to check and see if I'm right? Yeah, what should all 3 of these add up to make? And if they don't, I screwed something up. And even if they do add up to make 180, that still doesn't guarantee I'm right. Because if I set up the problem incorrectly, I can still get 3 angles that add up to make 180, but they don't meet the criteria. Right? What if I would have said, hey, the 3 angles are 60, 60, and 60? Is 60 plus 60 plus 60 180? Yeah. But does that meet the criteria? No. Okay, do you see? Okay, fine. So even if you check it and it matches, it still doesn't guarantee that you're right. I'm sorry. Any other questions before I do another one? Okay, here we go. Next problem. And that's going to take us to number 11. Number 11 has to do with rope cutting. So we have a rope that is 168 feet long, and we're going to cut it into 3 pieces. Got it? One rope. How many cuts? No. 2 cuts to make 3 pieces, right? I need 3 pieces, so it's going to require 2 cuts. Okay. It says the second piece is 6 feet less than 3 times the first. And the third piece is 2 feet more than 2/3 of the second. Find the length of the longest piece. So this time it doesn't say find the pieces, it says find the longest piece, and I'm going to have to give the right number, okay? Whichever one is longer. So now do you know where to start? Where did we start over here? Draw a picture. Where are we going to start this time? Draw a picture. So I've got my rope. I stretched it out straight. How many cuts? 2 cuts to make 3 pieces. And is it okay if we assume that this is first, second, and third? Going across? Okay. Now listen to me read it again. It says the second piece is 6 feet less than 3 times the first. Well, how long is the first piece? I don't know. What do we use for that? X. So since the second piece is based on the first piece, I'm going to have to call the first piece X, just X. Okay? And then I can write the second piece. 6 feet less than. Remember, less than is backwards. 6 feet less than, what did I say? 3 times the first, which is 3x. And do y'all see how that represents 3 times the first? And there's the second piece. Got it? Now for the third piece. The third piece is 2 feet more than. What is more than? Plus. 2 feet more than 2/3 of the second. 2/3 of the second. So what does the word of mean in math? Of in math is times. If you didn't know that, I'd make a note. 2/3 of means times. 2/3 of, 2/3 times the second. Okay, let me say it one more time, okay? The third piece is 2 feet more than 2/3 of the second. And so what's going to have to go in the parentheses? All of this stuff, right? Whatever the second is, that's going to go here. And so let's draw it like this. All of this is going to go there because it's 2/3 of the second. This one's a little more confusing, okay? But now do you understand how I got each one of those pieces? Okay, one more time. The second piece is 6 feet less than 3 times the first. The third piece is 2 feet more than 2/3 of the second. Right? And now can I set up an equation? Here we go. if I take the length of the first piece plus the length of the second piece plus the length of the third piece, if I add all three pieces together, should that give me the total length? And does anybody remember what I said the total length was?
168.
168. And so that should equal 168. Whew. Any questions?
On piece number 3,
Yes.
does it matter if you write 2 plus 2/3 of B, or do you have to write it with the first part and then plus 2? Does it matter whether you flip-flop?
Okay, so you're asking, does it matter whether the 2 goes in front?
Correct.
No, it doesn't.
Okay.
Okay? Now, if you were to ask me on this piece, does it matter whether the 6 goes in front? It does. Because if it says less than, the 6 has to go at the back. But if it's more than, the 2 can go front or back because addition is commutative. Have y'all heard of that word before? Addition is commutative. Do y'all know what that means? Commutative means order doesn't matter. Is subtraction commutative? In other words, is 6 minus 3 the same as 3 minus 6? No, and subtraction is not commutative, okay? Is getting dressed in the morning commutative? Okay? Does it matter if you put your sock on and then your shoe, or your shoe and then your sock? Yeah, so do y'all understand what commutative means? Order doesn't matter if it's commutative. Okay, fine. So all that to say it doesn't matter, okay? Wow, and so now I have an equation that I'm going to need to solve for x. And did y'all notice that we do have parentheses? And so the first thing I need to do is to get rid of the parentheses. What is the property that I'm going to use? Distributive. We're going to distribute the 2/3, which means that we're going to multiply 2/3 times the 3, and then multiply 2/3 times the 6. Okay, oh, and did you notice I went ahead and combined my like terms here at the front? 3x plus x is 4x. Oh, I put a plus, didn't I? Dadgummit. This is the second mistake I made today, right there. So 3x and x is 4x, minus 6 comes down, and then I need to distribute. So does anybody know what is 2/3 times 3? What is 2/3 times 3? Well, it's 2. Do you know why? Okay, I'll explain it. When you multiply a fraction times a whole number, you multiply by the top only. So what is 3 times 2? But then that's going to be 6 over 3. And what is 6 divided by 3? And that's how that works, okay? You multiply the 3 times the 2 and then divide by the 3. Let's do it again. What about 6 times 2? 12 divided by 3. And so that's going to be minus 4. How many of y'all have a calculator today? Like I recommended, okay? You can do this on the calculator if you want to. And so let's see. Oh, you got my calculator. Yeah. Oh, you did too. Okay. So let me give you the button for that. Do y'all see a button that looks like that? Box over box. This is your fraction button. And so to do this multiplication, you're going to do 2 fraction and 3. Got it? And then you're going to have to use the cursor to move out of the denominator. Y'all see the little keypad up top? Move out of the bottom and put times -6. Yep. Oh, look at that. And it says, hey, that's going to be -4. So if you're having trouble multiplying with fractions, the calculator is going to get you over that hurdle. How are we doing with button pushes over here? Okay, so let's go delete. Okay, so do you see where you're at? And do you see your cursor is in the denominator? So you're going to have to hit this button on the keypad to move over and then hit times -6. There you go. Bam. So that's how you use that calculator to do fractions. Anybody have a different calculator? They need calculator counseling. Oh. I don't see a single calculator on the background. Oh, look at that. That's a good one. That's the one I recommended. You were waiting to open it, weren't you, to make sure it was right? Yeah. Yeah.
So I have a graphing calculator, is that okay?
That's adequate, yeah. It'll do this stuff too. Any other questions before I keep going? Okay, so now that I've gotten rid of the parentheses, next I need to CLT. Combine like terms. I've got a 4x plus a 2x. And I've got -6 and a -4 and a +2. And then I think from here it's gravy. That means easy. Yeah, so from here, we're just going to bring the -8 over, which makes it a +8, which is what? 176. Divide both sides by 6. Man, I hope that divides evenly.
No.
Oh, what'd you get?
88 over 3.
88 over 3. And I'm going to illustrate something about the calculator that I use, okay? If you enter 176 over 6, notice the calculator reduces it to lowest terms automatically. So this is as much as this fraction is going to reduce. But this is not a whole number, right? So what if I wanted a decimal? What button would I push? Can I show you? SD. Bam. SD.
29. What, okay.
SD makes a decimal.
What is the line over the last number? Does that mean it continues?
That means it repeats, which is another cool thing about my calculator is it gives you the bar notation. If you hit SD again, it'll show you it repeats. And then if you hit SD again, it goes back to the 88 over 3, which is freaking cool. Now, let's say that this is the length of the first piece, but I can't really tell how long that is, right? If somebody says, hey, I need you to measure and cut 88 over 3 feet, I'm going to go, what are you talking about? Right? What is that? It would be way better if I had a mixed number. And so let's see how to make this a mixed number. That's going to be Shift SD. Shift SD. And what does that give?
29 and 1/3.
Now, if you're doing this by hand and you want to get a mixed number, you're going to have to divide like you did back in 4th grade. you're going to have to set it up 88 divided by 3, and you're going to have to do the, you know what I'm talking about, the long division, and then figure out what the remainder is and put it over the divisor. So this shows you're going to get a remainder of 1. 1 over 3 is the remainder. Crazy stuff. Thank God for the calculator. I also want the decimal. And I heard you say that it gave a line over it. And so if I use the bar notation, this answer is equivalent to these two. Do y'all understand the bar means it repeats? And therefore, this answer is exact. It's the same as these other two. What if I don't put the bar over the 3? Then is it exact? No, it's approximate. Because if you only put 1 3, really there's an infinite number of 3s, right? Y'all follow me? With the bar notation, there's an infinite number of 3s. If I don't put the bar, then the answer is approximate. Do y'all understand the difference between exact and approximate? Do you? Okay, I'll give you an example. What if your paycheck was $1,535 and your boss says, oh, I'm just going to approximate your pay, here's $1,500. Would y'all be happy with that? 1,500, what did I say, 30 something dollars? And he said, I'm just going to round it down and approximate it $1,500. I'm not going to be happy with that either because I'm missing some money. Just like I'm not going to be happy with this answer if you don't put the line because it's missing some stuff. Y'all look awful. Y'all are already ready to go, I can tell. Okay, let me again emphasize what I'm trying to say here. On a test, if the instructions say give the exact value and you don't put the bar, it's wrong. It's not the exact, okay? But what if I said round to the nearest 10th? Then I don't want the bar. I want it rounded, okay? There's a difference between exact and approximate. And I don't know if you understand, but we're not done. Because this problem said find the longest piece. Do I know that the first piece is longest? I don't know. So I'm going to have to find the other pieces as well. This is the first piece, okay? Let's find the second piece. If I know the first piece, can I get the second? Yes. Because look up here, the second piece is 3 times the first minus 6. So we're going to go 3 times the first minus 6. Now, did you also notice that I chose to use the improper fraction? Of all of these 3 choices, I chose the improper. Do you see why I chose that one? It's the easiest to work with. What's going to happen to these 3s? Yeah, they're going to cancel. And so 88 minus 6, and that is definitely longer than 29 1/3 feet. So at this point, now the second piece looks to be the longest. But I'm going to have to find the third piece just to make sure that it's not the longest. All right, so here we go. Third piece. That's going to be 2/3 of. Do you remember when I read it to you? It was 2/3 of the second. And so what was the second piece? 82. 2/3 of the second plus 2. If I scroll up and look at that, 2/3 of the second plus 2. And so I need somebody with a calculator that knows how to use it to give me that value. 170 over 3.
It looks right.
Okay. What is that as a mixed number?
56 and 2 thirds.
56 and 2/3? Is 56 and 2/3 longer than 82? No. So which piece is the longest? The second piece. Now, do you understand that when you're doing your My Math Lab problems, if it asks you what is the longest piece, it may give you an option first, second, or third. And then you'll have to pick which one is longest, or you'll have to input 82 because it's the longest piece. Anybody have any questions so far? Yeah.
Why did the 3 cancel out for the second piece?
Right here?
Yeah.
Why is that?
Because it would be like you put 3 over 1.
Yeah, I'm trying to figure out the best way to explain. I think I like what you said. So if I have a whole number 3, I can make it a fraction by putting it over 1. And then when you multiply fractions, you go straight across. So that'll give me 3 times 88 over 1 times 3. And now I can see that the top and the bottom have a common factor of 3. And so that'll reduce. That's why the 3's cancel. Is because you're going to have a 3 in the top and the bottom. Anybody else have a question? Okay, I've got more problems to do. Next, number 17. And this one has to do with interstate mile markers. It says U.S. interstate highways post numbered markers every mile to indicate location in case of an accident or breakdown. I don't really care about that. I could care less. Have y'all know what they're talking about? Have y'all ever driven and seen mile markers? Like it'll say mile 182, and then you drive a little ways and it says mile, and then yeah, okay. So they either increase or decrease depending on whether you're going into the state or out of the state, okay? But the main thing is, if you go from one to the next, how much do they increase or decrease? 1, right? It either goes up a mile every time or it goes down a mile every time. Y'all got that? Now, the problem says the sum of 2 consecutive mile markers is 459. What does the word sum mean in math? Add. So if I take the first mile marker and add the second mile marker, it should add to make 459. And did y'all hear them say consecutive? What does consecutive mean? One after the other, right? One after the other. So what is the number on the first mile marker? Or do we not know? I don't know. And so what do we use for that? X. Do y'all see the first one? I don't know what the first one is, but now that I know what the first one is, now I can write the second one. The second one is always whatever the first one was plus 1, right? Because they increase by 1. Or if I'm going out of state, this could also be x minus 1 if they're going down, okay? So do you see that this could be plus 1 or minus 1 depending on which way I'm going? We're going to assume that they're increasing.
Do you always assume if they don't convention?
No, you don't always. You know what? Have you ever seen that breaking down the word? You don't always assume, okay? Because you'll make a. Okay, so don't do that. So what we're going to do is we're going to assume it's plus 1. We're going to work it out and see what we get. Do y'all understand the equation? The first plus the second equals 459. And now let's combine like terms. How many x's do I have? 2. X plus x, 2x. What about if I bring the plus 1 over? Minus 1 makes 458. And then divide both sides by 2. So I can tell that the first mile marker had the number 229 on it. What does the next mile marker have on it? And do y'all understand why it's 230? It's because I assumed that they increase. 229, the next one is 230. Yes or no? Now, let's go back and let's play the what if game. What if they're decreasing? What would the second one be? X minus 1, and they still add up to 459. And I'm kind of curious to see if I get the same answer if they're decreasing. So, x plus x, 2x. This time, minus 1 is going to move over and become plus 1. Kick that up to 460. And then divide by 2. 230, which does match the 230. But then what would the next mile marker be? 231? 229. Because I assumed they were decreasing, right? Wow, isn't that cool? I get the same answer. So it doesn't matter whether I set it up that they're increasing or decreasing. I get the same answers. The only difference is if it said, which one do you encounter first, then it'll matter. Because if they're increasing, I encounter the 229 first. But if they're decreasing, I encounter the 230 first. Y'all understand that? Depending on which way I'm going to hit one or the other first. So hopefully they will specify. And I've got one more problem and then I'm done with this section. Any questions? Okay, here we go. Last problem for this section is number 25. And for number 25, they do give me the formula. I don't have to come up with it. And since they give me the formula, I think it's important that we understand what it represents. Like, what is this formula telling me? This particular formula describes how much money is spent on internet advertising based on what year it is. Okay? So the X is going to represent how many years after a certain date. And the Y is going to be how much money you spent. You follow me? So if I plug in an amount of time, it's going to calculate an amount of dollars. Have y'all ever seen a formula like that before? Have you ever had a job? Right? So if you have a job and you're working hourly, they plug in the number of hours you work and calculate how much money you make, right? That's exactly what this is doing here. All right, so let's make a note here. X is the number of hours, not hours. Why am I saying hours? Number of years after 2012. And Y is money in billions of dollars. Part A. We know that X is the number of years after 2012. What part A asks us to do is calculate how much money was spent in 2014. So you're going to have to figure out how many years after 2012 is 2014. And that is 2. And so that tells me that I'm going to substitute 2 in for X. So Y is going to be 6.5 times 2 plus 41.6. And what a great time to have a calculator right there. You just plug all of that into the calculator and it spits out 54.6. And remember, that is billions. So companies spent $54.6 billion on internet advertising in 2014. That's what that tells me. And so what year is it now? I'm kind of curious if this formula holds true. I want to know how much money they're spending now. So in 2020, how many years after 2012 is today? How many? 8. 8 years from 2012 is 2020. Let's plug in and see how much money they're spending this year. And can y'all see that advertisers are increasing how much money they spend on internet advertising each year? And that should be a common sense thing, right? Fewer and fewer people are reading the newspaper, reading magazines. So advertisers are moving their advertising into the medium that people are spending more of their time in, which is online, right? Does that make sense to you? Okay. Now we're going to do part B. And B stands for backwards. We're going to do it backwards. Part B says, in what year will the spending reach 75 billion? In what year did they spend $75 billion? And so now if I look at my formula, where does the 75 go? In for Y, and I'm going to calculate X. Everybody understand why the 75 plugs into Y and not X? Because X is time, Y is money. And so what am I going to have to do to solve for X? Well, we're going to have to move the 41.6 over, which is going to be minus 41.6, which is going to be, I have no idea. I'm going to rely on the calculator users for that.
33.4.
And then what do I do to both sides to get X by itself? And what happens if you divide by 6.5? I would like that rounded to the nearest whole number. To the nearest whole number. Got it? 5. Did anybody else using a calculator get 5 point something? Okay, but what is the first number after the decimal? Okay, 5.1, if I round that to the nearest whole number, means 5. What if it was 5.6? Then it would round up to a 6, right? 5.6 rounds up. What about 5.4? Stays 5. Y'all know how to round, right? That's kind of important. Now, do y'all understand if this was a My Math Lab problem, you could calculate this and put in 5 and it could still count it wrong. Because there's another way I could write this answer. This tells me how many years, but does it tell me when it happens? They might be asking what year does that happen in, and you need to know how to find that. So what year did we start counting from? So what is 5 years after 2012? And you will have to know what they're asking for in order to get the right answer. Because you can get the right answer and put it in and it's not what they asked for. And if y'all don't have any more questions, that is it for section 1.3. Questions before I move on? Okay, here we go. 1.4. What did I just do? Oh, I did add a page. Delete. All right, so we're moving on to section 1.4, and that's going to take us to page 44 if you need to know that. Page 44 in the text. And this section has to do with sets, inequalities, and interval notation. That is what the section is titled. Sets, inequalities, and interval notation, with an emphasis on inequalities. What we're going to focus on mostly. And the first problem, the first example, number 8. And that's what the problem looks like. Plus? Oh, that's a T. Yeah, that's the way I write a T. That's a T and that's a T. Oh, and do y'all know what that first symbol is? I covered that, right? That's a brace. And do y'all remember what I said braces indicate? What was it? A set. So when you see braces, that says, hey, this is a set of something. And just so you know, the way this is written, this is actually called set notation. Set notation. And I guess it would be nice if you know how to read this out loud to somebody. Well, I don't know, like you might call your mom or dad and say, hey, I've got this problem, and then you read it to them, and they help you solve it, right? Okay, you need to know how to read this out loud, okay? So when you see the brace here at the beginning, this says the set of all T. The set of all T. And then what about this symbol? That is the words such that. This bar means the word such that. So this is the set of all t such that t is greater than negative 10 and t is less than or equal to 10. I'll say it again. The set of all t such that t is greater than negative 10 and t is less than or equal to 10.
So why did you skip?
Over,
Yeah.
because it's easier to read it with t being first.
But you can't write it that way?
You could. You could. This turns out to be more efficient mathematically to write it as a single statement rather than two separate. Okay? So do y'all see that the t is in between these two? Okay? So what I'm going to do is I'm going to read, although this is a less than symbol, if I read it backwards, do y'all remember the alligator eats the big one? So since he's eating the t is bigger than negative 10. And now the t is on this side, so t is less than or equal to 10. So if it's greater than negative 10 and is less than or equal to 10, does that mean that it's between those two? The answer is yes. Whatever t is, it's between these two numbers, okay? Okay, fine. Let's move on and look at what they want us to do. The instructions say write interval notation for the given statement. We're going to convert this from set notation into interval notation. And the easiest way to do that is to do an in-between step where we make a number line. So can y'all see that there are two critical points? I need to put those on the number line. Negative 10 and 10. And do y'all remember back when you did this in public school? Remember you either used an open circle or a solid dot, depending on what the symbol said? And so does the negative 10 get an open circle or a solid dot? Yeah, he's open. You know why? Because his inequality doesn't have the equal to. What does the positive 10 get? Solid. He's got the equal. He's going to be solid. So far, so good? And then we know the shading is going to be in the middle. Because it says t is less than or equal to 10, which has to be to the left of 10. But if it's bigger than negative 10, it's going to have to be to the right. Do y'all understand that? And now that I've got a graph, it's going to be a lot easier to write the interval notation. So what interval notation says is it says what is shaded from left to right. Okay? So as I'm moving from left to right, where does the shading start? At negative 10. And would I use a bracket or a parenthesis? Yeah, that's going to be a parenthesis because it was an open circle. Open circle corresponds to parenthesis. What do you think a solid dot corresponds to? Bracket. And then that is interval notation. And do you see how that describes what is shaded? Look what this says. It says everything from negative 10, and the parenthesis says not including negative 10. Everything from negative 10, but not including negative 10, up to positive 10, and including 10. Y'all understand the difference between including and not including, right? What is that like in the real world? Everything up to but not including. Has anybody ever had to do income tax before? like an income tax form. And you know, depending on how much money you make, you fall into different brackets. And so it might say if you earn up to $15,000, but not including $15,000, because if you're equal to $15,000, you get bumped up to the next one. So if you earn $1499.99, you're in this bracket. But then when you bump up to the next one, if it's including, then you go to the next. Y'all see the difference? Okay. Yeah, so we did 3 things there. Y'all got to look at set notation, you got to look at the number line, and interval notation. Let's move on to number 13. And so what they've done for number 13 is they've just given you the number line that is shaded, and they want you to write the interval notation. In other words, they want you to describe what is shaded with interval notation. Did y'all hear me say that interval notation has to go from left to right? So where does this shading start? Right here, and they labeled that negative square root of 2. Now, did y'all also notice that instead of using an open circle, they used a parenthesis? And you can use either one of those interchangeably. An open circle and a parenthesis, they mean the same thing. So that's going to be negative square root of 2 with a parenthesis. That's where the shading starts. And then where does the shading stop? Infinity. Do you see there is no stop? It says it keeps going. And if it goes off the number line to the right, that's positive infinity. What if it shades off the number line to the left? Well, that's negative infinity. And that's the answer for that problem.
And you close it with a parenthesis.
Infinity gets a parenthesis. Did y'all get that? Infinity, parenthesis. It even rhymes. Do you ever put a bracket on an infinity? No. Infinity, parenthesis. Got it? Okay, let's do number 14. Shade. And number 14 is exactly like number 13, but it's different. It's exactly the same, but it's different. They still give me a number line. They still want the interval notation, but the shading is different. Okay? So I need the interval notation. Where does the shading start? At negative infinity. And the reason is because you have to go from left to right. Where does the shading start? A stop. 8 with a bracket. Now the 8 gets a bracket. Why? Because it had a bracket up here. And what is a bracket synonymous with? A dot. Solid dot, bracket, open circle, parenthesis. Y'all got that now? Okay. Are you ready to go to the next problem? I'll take that as a yes. Number 25. All right, so number 25, this is where we actually get into solving inequalities. Now you're going to have to get x by itself, and you're going to have to write the solution, okay? Now, as far as the solution goes, there's going to be three answers I want, okay? I want set notation, I want the number line graph, and I want interval notation. Got it? I want it all. And so what we're going to do first is we're going to have to get x by itself. Who needs to move over? And do y'all see that the inequalities work just like an equation as far as solving them? We're going to move the negative 11 over. That's going to make plus 11. And then that's going to say x is less than or equal to 9. Y'all got that? Now that is the solution, but it is not in one of the notations. It is the solution. It does tell me what x has to do, right? Are y'all with me? And the easiest thing to get first is set notation. Watch how freaking easy this is. All you got to do is put a brace, another x, a vertical bar, and another brace. Man, if you can just solve these for x, set notation is freaking easy. You just got to put the braces, the extra x, and the vertical bar. And that's set notation. Questions?
Can you remind me what the vertical?
Oh, yeah. Such that. So this says the answer is the set of all x such that, and then this is what x has to do. What it says is, it says, hey, all of the x's that are less than or equal to 9 are solution. Okay? So now let's go to the number line. What is my critical point? 9. Is that going to be an open circle or a solid dot? And, I'm sorry, you said or a bracket. Because I could use a bracket or a solid dot and it's the same, okay? I will. Now, when it comes to doing it on my math lab, it'll be specific as to whether it's a dot or a bracket, okay? But on a written test, I'll be happy with either, okay? Now, am I going to shade to the right or the left? Right or left? Left. Yeah, and it's not necessarily because it's behind it. It's because this says x has to be less than or equal to 9. And what kind of numbers are less than 9? Numbers to the left are less, right? Hello, yeah. To the left means we're getting smaller. Okay, I'll give you something else that'll help you, okay? This is the way I normally teach it. Look at the inequality. Is the letter on the left? If the letter is on the left, you shade the way the arrow points. Okay? If the letter is on the left, shade the way the arrow points. So what if the letter was over here? Then you would shade opposite of the way it points. Got it? If the letter's on the left, shade the way the inequality points. Okay. And now I need interval notation. So where does this shading start? Negative infinity. Is that going to get a bracket or a parenthesis? And where does the shading stop? Bracket or parenthesis? And that is interval notation. Questions? Next problem, number 29. And we're going to do it again. We're going to solve for x, and we're going to give all three answers. Now this time, what am I going to have to do to get x by itself? I'm going to have to divide, right? Because the 0.3 is multiplied. So we're going to have to divide by 0.3. And does it matter if I put the 0 in front of the decimal? Is 0.3 the same as 0.3? Okay, so that's optional. I don't have to put the 0. Those are going to cancel. Negative 18 divided by 0.3. Survey says? Okay, I think it's 60. Y'all might want to check with your calculator.
Yes.
Is it 60? Okay. Whew. I wasn't sure. That's what we got last hour, but I wasn't sure it's still the same this hour. Now, is that set notation? No, but it's really close, right? To set notation. I just need a brace and an X and a bar and a brace. And then that's set notation. Okay, next, let's go to the number line. What is my critical point? Negative 60, open or solid? Open. And which way do I shade? Left or right? Left. I said it that way just to see if you'd switch. Yeah, it's left. Why is it left? Because X is on the left, so I can shade the way the inequality points, to the left. Now, let's do interval notation. Where does the shading start? And where does it stop? Bracket or parenthesis? And so this time they both get parentheses. Is this easy enough? I'm trying to make it as easy as I can. Okay. Any questions? I'm not done. We got another one to do, okay? And now we're going to crank it up a notch. Yeah, number 41. Number 41, the instructions say solve, graph, and interval notation. So we're going to do all three answers again. There's a lot of stuff there. Now listen, you've got a decision to make. Do you want to move the 2y over or the 5y over? Huh? Does it matter? Yes and no. No, it doesn't matter unless it matters to you. Okay? It's kind of like if you order a hamburger and they say, do you want ketchup or mustard? Does it matter? To some of you, it's like, yeah, it matters. And then some of you are like, I don't care. I eat them both, right? So it matters if it matters to you. So which one do y'all want to move? You want to move the 2. Now, if I move the 2y, who else needs to move? The 9. right? Because I want to get all the letters on one side and everybody else on the other. So the negative 9 is going to become positive 9. And the 2y becomes minus 2y. 7 minus 9 is 2. 5 minus 2 is 3. Divide both sides by 3. And I don't think that divides nicely. So we're going to leave that a fraction, 2/3. And do you see that that does get y by itself? But remember me saying a second ago, I said if the letter's on the left, you can shade the way the arrow points. Is the letter on the left? No. So when it comes to the number line, I'm going to have to remember maybe to shade opposite, okay? Or can I go ahead and fix this and make the letter on the left? I can. Or I can take the whole thing and just flip it. Flip it around. So it'll say y is greater than 2/3.
Would it have solved with the second solution had we moved the 5 over?
And I'm going to show that. Yes. So this answer is better because when I come to the number line and I need to know which way do I shade, I can simply shade the way the arrow points. Why? Because the letter is on the left. Okay, so that's better. So now let's go to the number line. What is my critical point? Open or solid? Shade to the right. Shade to the right. Everybody see why it shades to the right? Okay, so now what is the interval notation? Everything from 2/3 to and beyond. And do they both get parentheses? Yes, they do. All right. So I'm going to do one more problem. Do y'all have any questions about that? Nobody? Okay. So the last problem that I'm going to look at today is number 41. Yeah, I'm going to do a Britney Spears. Do you know what that means? Oops, I did it again. I'm going to do it again. Oops, I did it again. I worked the same problem and got the same answer. Oh, baby. Yeah, I'm going to do it again. Okay? So, last time we moved the 2y, right? And so this time I'm going to say, well, what if we would have chose to move the 5y? Who else would need to move? The 7. So then that's going to be 2y minus 5y. That's going to be 7 minus 9. Y'all see the difference? Now, what is 2 minus 5? Negative 3. 7 minus 9? Negative 2. And now what do I need to divide by to get y by itself? What kind of 3? Uh-oh, warning. Danger, Will Robinson. Guess what happens if you divide both sides by a negative? You got to flip the inequality.
But then do the two,
Do the two negatives
yes.
cancel? Yes, they do. Because a negative divided by a negative makes a positive. But the thing you have to remember when you're working with inequalities If you divide both sides by a negative, what do you have to do? You're going to have to flip the inequality. And do y'all see that that matches the answer we got before? So does it matter which side I move the letters to? No, it makes no difference. You'll end up with the same answer. But this is super important. I'll say it again. If you divide both sides by a negative, you have to flip the inequality. And then I'm pretty sure we can get the same graph and interval notation from there, right? Okay, so I've got a few more minutes. Would y'all like to see any more problems, or do you have any questions?